Hi and welcome to Jawad's Academy. Our today's lesson is about derivatives of any relation using power rule. First of all, what is derivative? Derivative is allowing us to find an expression for slope of a tangent or instantaneous rate of change. In this case, y prime f at prime of x dy by dx is indication that you're looking for or finding the derivative of y respect to x. So here is a general form in order to use power rule to find the derivative of this expression. Y equals a times x to the power of n. A is the coefficient of x to the power of n, and n is the degree of x. N can be anything but 0, same as a. A can be anything but 0, can be positive, negative, fractions, decimals, anything. So now to use power rule, how does it work? We always multiply the coefficient of x times n, and then we subtract 1 from n, the degree of x. So derivative means you're always reducing the degree of a relation by 1. If you were to find the derivative of quadratic relation, you will end up having a linear equation. If you were to find the derivative of a cubic function, you will have at the end a quadratic relation once you find its derivative. So let's apply here power rule, as we said, to find the derivative of this expression. We said we're going to multiply the coefficient of x times the exponent, whatever it is, of x. Then we reduce 1 from its degree, so we subtract 1 from n. This is an expression for slope of a tangent using power rule. What is the derivative of constant? The derivative of constant without any variable is equal to 0. For example, y equals 2, and the derivative of this y prime would equal to 0. Why is that? Let's prove using some basic skills that we learned back in lower grades, exponent laws. If you remember, we said x to the power of 0 is equal to 1, and that's true, and I'm sure you know that. So I'm just going to use this basic skill in order to prove that the derivative of the constant is equals to 0. So I'm going to rewrite my expression. I'm going to push this a little bit up in order to get more space. So I'm going to write y equals, right here, this expression, 2 times 1. So I'm not changing anything. I'm just rewriting it as 2 times 1, which means still 2. And then I'm going to replace 1 as x to the power of 0. 2 times x to the power of 0 still means 2. So I'm not changing the value of the expression. I'm just going to show you that y the derivative of the constant is equals to 0 right here. So now I'm going to apply here power rule. We said coefficient multiplies by the exponent, so y prime equals 2 times 0 is 0, and we subtract 1 from the exponent, so it'll be negative 1. Now we can see that 0 times anything is always equals to 0, regardless what the variable is to the exponent or anything in front of 0 is. So 0 times anything is always equal to 0. So now you know that the derivative of any constant is equal to 0. So now let's do more examples using power rule. So I'm going to again push this a bit up in order to get space. I'm sure you can always pause the video and rewind to see what's going on. And to understand better, of course, to understand the steps, what is power rule, what is derivative in general. So an example would be using power rule, y equals 4x to the power of 3 plus 2x squared minus x minus 1. Now we're going to apply power rule through each of these terms separately. Just look at it like that. It's a lot easy. So y prime, so we're finding the derivative of y respect to x always. The coefficient of this here monomial 4 times x to the power of 3. So we said to use power rule for this right here, this term, it'd be 4 times 3, and then we subtract 1 from the exponent. The coefficient multiplies by the exponent. So it'd be 12x to the power of 2. That's the derivative of this term. Plus 2 times 2 is 4, so we subtract 1 from the exponent, will be x to the power of 1. Now, the derivative of this, negative 1x. So negative 1 times 1 is negative 1. When we subtract 1 from the exponent, it will be 0, but x to the power of 0 is equal to 1. We mentioned that earlier. And the derivative of the constant right here, it would be 0, so we don't have to write it. So therefore, our derivative of this cubic function would be a quadratic relation and standard form. So you can see that we reduce the degree of this polynomials by 1 through each terms. That's how we do power rule. Let's do another example without using polynomials. Any other relation, we still should be able to use power rule to find an expression for slope of a tangent. So I'm going to push this more here, and there you go. So example 2. Y equals 1 over square root of x, for example, minus 2x to the power of negative 3 plus a constant. So we have 3 terms, and each terms we're going to apply power rule. But before we do that, we have to rearrange some of these terms in order to use power rule. So I'm going to rearrange 1 over square root of x as, I'm going to rewrite it as x to the negative half. Because square root of x can be written as x to the half. Since it's in the bottom, when you flip it, the exponent becomes negative, using, again, basic skills, exponent laws that we've learned in lower grades. So leave this as it is because it's ready to do the derivative of each term using power rule. Now, how power rule works, we said the coefficient times the exponent, and we subtract 1 from the exponent. The coefficient of square root of x to the negative half would be 1. So the derivative is negative half times 1, it'd be negative half. And then we subtract 1 from negative half, it will be negative 3 half. Negative 2 times negative 3 is positive 6. When we subtract 1 from negative 3, it'd be negative 4. And the constant will equal to 0. So this is the derivative of example 2, this expression right here. So that's an example, and this is the derivative of this, meaning that this is an expression for slope of a tangent. If you were to given a value for x, substitute to find the exact value of slope of a tangent. Hope this lesson was productive and very useful. Please don't forget to subscribe, thumbs up, and if you have any question, please leave below in comment box and I'll get back to that as soon as I can. Take care and see you next time.